Hi everyone, welcome to the module on functions. So, using functions. Believe it or not, we've actually used many functions already in the previous modules, and some examples include the print function, the integer function, the input function, and the range function. So these are some examples we've put up here. Now, I'm not sure if you've noticed or not, but a lot of these functions, in fact all of them, have a bracket next to them and something in these brackets as well. So these functions, they have a name and they have a parameter that they take in order to perform some task with these parameters. So a parameter is just a value that you pass into a function to tell it what to do with it. So other than these functions that have been predefined by Python, most languages do let you define your own functions so you can customize them. So how do you define a function? The first thing you would need is the def keyword. So that pretty much says that everything from here onwards is me defining my function. And after that, you would need the name of the function. In this case, it's some function, and a bracket, and inside this bracket is where you put your parameter list. Now, a parameter list is optional. You don't always have to take in parameters. If you want to take in one parameter, just put the name of the parameter there. If you want to take in two parameters, you can put a comma here and list the second one, and so on. And if you don't want to use any parameter at all, just have a bracket with nothing inside it. So once you've done that first statement, the colon indicates that it's the start of the body, and the body pretty much says what exactly the function should be doing. So in this case, the function has a variable called summation, and it runs through the number list using a for loop, and it pretty much increments summation by each of the numbers in the number list. So what this function does is it just calculates the sum of all the numbers in this parameter number list, and it returns what the value of that is. So now the return statement is also optional, and it's pretty much like saying, hey, if you want the function to give you back the answer of what it did, include the return statement, and what answer do you want to return? That's what you would have after the keyword return. So to call a function, you will need its name. So remember from the previous slide, the name here was some function. Here as well, we've got some function as the name, and the arguments. So the number of arguments here and the type of arguments has to match the definition. So in this case, we have asked for a list and only one list, no more than one. So even here, we are passing it one list called myList, which has been specified here, and there are only numbers in this list as well. So we pass that in, and somewhere to assign the results. This is only for functions which return something. So what that means is, if we take an analogy of, say, a minion, and you tell the minion, hey minion, here's my list, can you please go off and do the sum of every number in this list and bring me back the answer to that? That is pretty much the return statement. So it's like you're telling the minion, I want you to actually come back and tell me the answer and not just disappear with it. So once you have done everything in the body, bring me back the answer. So the minion brings back the answer, and they're like, well, who do I give it to? Give it to my colleague, my sum. So my sum is what holds the answer of whatever is returned from this function. So if you do return something and you want to do something with that answer, make sure to actually assign it to a variable so you don't just lose it. And then once you print my sum, it will print the sum of all of these numbers in the list. Now, returning something that we've already touched upon, it's used to get your results back out of your function. If we look at this code here, it's pretty much the same as before, except there is no return statement. So it's like saying, hey minion, your name is some function, here, take my list, do all of this summation inside, but don't worry about it, I don't want the answer. That's what the return statement, the lack thereof, is indicating. So if we look at this, my list equals 1, 2, 3, 4, 5 like before, and the code is pretty much all the same, except that there is no return statement. So when you actually print this, what is returned is a none object. That pretty much says that there is no answer to return. What are you asking me for? So if you do want to have an answer that you're going to use in your code, once again, make sure that you actually assign it to something. So it's actually quite similar to a couple of slides before when we have this line over here. So you're asking it to convert your input into an integer. So if you just did not have the end equals and you just had the rest of the line, it will convert it into integer, but it just won't store it anywhere, which is why it's really important that if your function returns something, store it in a variable. This is a really good place to actually write our own function. So moving over to Pycharm. The function that we will be writing today is a function that takes in a parameter as a list of numbers, and it returns the maximum number in that list, so the biggest number in that list. So the first thing we're going to do is type in the keyword def, and we have to always give a meaningful name to a function so that we know what the function is doing. So in this case, because we're saying get maximum number, we'll call it getMax. Now, something else to be careful of is you might want to call your function as max, and then you do that. But if you hover over it, Python says that there is already a built-in function called max, which means you can't really take the same name as a function that already exists and try and customize it. Python doesn't allow you to do that. So create your own name, getMax. Now, inside here, I did say that we will take in a list of numbers as a parameter, so let's call it number list. Now we're into the body of the function. So we want to get the maximum of all of the numbers in the list. So we have to start somewhere. So let's just say the maximum for now is the first element of number list. So we have started somewhere. Now we want to iterate through the whole list and check, is this maximum really the maximum, or can I find a number bigger than that? So for this, we're going to use a for loop, and the reason we don't use a while loop is because with the for loop, we already know just how many iterations we need to do, so that will do for for loop. So for number in number list, so for each number, let's check if this number is greater than my maximum. Let's update maximum. So what this is doing is it's going through each of the numbers in the number list and checking, is this number greater than maximum? If it is, then reassign maximum to this number so that there is a new maximum now. So for example, if the very second element is already bigger than this first element, it's going to change the value of maximum to whatever the second element number is. Remember that with this function, we do actually want a return statement, like we want to get out the answer of what the largest number is. So let us return maximum. So that's that. So that's our function done. Now let's run it. Nothing's happened. It's not because there's a problem in my code in terms of the syntax or the logic, but it's because I didn't actually call my function. So all the definition does is it tells Python, hey Python, if someone ever calls me, called getMax, then do this. So I need to actually call the function. So let's just make another variable, my list equals 4, 6, 8, 99 minus 1. And now I'm going to pass in my list to get max, my list. Now let's run the code. Okay, nothing happened once again. Why is that? It's something that I mentioned before about actually returning something is one thing, but holding the result of it in a variable is another thing. So because we actually want to do something with what is returned, we are going to assign it to a variable called my max equals. And now to actually see what it is, let's just print my max. There we go, and that's 99. There's a much shorter way of doing all of this. So instead of doing all of that, if you don't want to, create your own list variable, if you don't want to assign it to my max, you just want the result immediately printed out, what you could do is and put in the list over here. Don't quite remember the numbers. We'll make another list. Put in the white space as required, and let's run that. And 99 once again. So all it does is it's condensing down the lines of code. So it's immediately calling getMax on that list, and whatever result you get out of getMax, just print that. So that's a shorter way of doing it. Now, There are different types of variables in a program. There is a local variable and a global variable, and this is called the scope of a variable. So local variables are some things that are defined only within a function. So for example, username over here. They can only be accessed inside this little function, and they really don't exist outside of that block. Global variables, on the other hand, are defined outside any sort of blocks, and they can be accessed from anywhere within the program. So let's just try an example with that. So let's just go with the same username example with my name. And let's just say define print name, doesn't take any parameters, and say print username. Okay, so if we look at this and we actually call print name and we run that, it's going to print my name, and there's no problem. Python's fine with that. But if we move this username to inside this statement, okay, there's still no problem. It can still print my name. But if I say print username, there's a red squiggly line, and it says there is no reference to username. What's username? What are you talking about? But if I had this outside of the function, it is able to print username. It knows where it is. So the point here is that when username is not inside a little block of function, that means it can be accessed from anywhere outside, and it doesn't necessarily have to be not referenceable or anything like that. But if it's only inside this function or any function, only that code inside the function can access it. Once you come out of the code, it doesn't exist anymore. An analogy for this is if there is a power outage in the whole country, even the city is going to be, a little city is going to be affected by it. But if there's a power outage only in the little city, the rest of the country really doesn't care about it. So that's what global variable is. So this is a global variable. And if I had that inside a function, it's a local variable. And the last thing we'll go through in this module are these functions called recursive functions. These ones are a little bit more difficult to write up and execute, but are really, really useful. So it's essentially a function that calls itself. So it's recursion. And checks need to be included to actually end the recursive calls once a condition is met. Think of it almost like Inception, where you go down different levels. So what this code is doing here is it goes down different levels of the same function. So we'll actually code it up to see how it works. So what we're trying to do with this code is we are trying to take an integer number from the user as a parameter, and we're going to print out every number before it until 1. So for example, if we take the number 10, then the program is supposed to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then stop. So let's define a function called recursive count, because we are counting using recursion, and let's take n as an input, and with n being an integer. So if n is greater than 0, because we only want to print until 1, we don't really care about 0. If that's the case, print the n and go back down 1 level. So this here, this return statement, is pretty much saying, okay, take n, subtract 1 from it, and then run the whole program once again. So if we have an example of, say, 3 as n, so is 3 greater than 0? Yep, okay, let's print 3, and then let's return whatever the output of this function is for 3 minus 1. So 3 minus 1 is 2. So what it does is, it doesn't delete this function, it replicates this function again, and it runs it, but this time with 2 as the parameter. So is 2 greater than 0? Yep, let me print 2, and let me do 2 minus 1, which is 1. So once again, make a replicate, and this time with parameter as 1. Is 1 greater than 0? Yep, let me print 1, and now let me do 1, take away 1, which is 0. Run this function again with parameter 0. Is 0 greater than 0? Nope. Okay, I'm just going to quit this, go back to where I was called. So now the go back to where I was called is actually a bit of a difficult concept. So what I'm going to do is I will first run this function. Remember, you have to actually call the function to run it. So we're going to go with 5 as our recursive count for now. So with 5 as our recursive count, let's try running this. There we go. 5, 4, 3, 2, 1. Now I want to show this in a visualizer, so the debugger, and let's actually try it with a slightly lower number. And remember, to use the debugger, you need to have put a breakpoint somewhere. So we're going to do it over there. So now this time we're running it with 3. So the expected output is 3, 2, 1. Alright, so let's try running it. Use the bug. So the first time it's running it, n equals 3. Okay, so n is greater than 3, so it goes inside the if block. Alright, and it prints out n for us. And now it's going to return whatever the result of recursive count 3 minus 1 is. So see where it goes now. It does the same function with 2, because 3 take away 1 is 2. And something that I want you to notice here is, if we look at all the methods that are running, there is the first recursive count, and see how it has replicated itself to run once again for n equals 2. So that pretty much means that the first one, it's still existing, but it's waiting to see what the result of this is. So now we're computing this. So let's go through it again. It's printing n. Okay. And now this function is going to wait for the result of the third recursive count function, this time with n equals 1. Okay, so we're printing n once again, return recursive count. Now this function is going to wait for the output of parameter 0. But this time it's not going to go inside because we know n equals 0. And now see how n is 1? That pretty much means that the n equals 0 function is no longer there, like it's gone now. And it's come back to the n equals 1 function to return whatever it did there. Because remember, we went down levels over here. So if we took a staircase through the return statement, we have to take a staircase back up the return statement. So we do go back again and see now we're coming back levels, 1, 2, and then we're going to go back the last level, 3. And see how the recursive count methods have also started disappearing. There's only one method, which is what we're in right now. And that's it. That's the end of recursive count. So that is pretty much recursion, and it's super important to actually have a check condition. So in this case, our check condition was if n is greater than 0. If you don't have that, it's going to keep on running pretty much like an infinite loop, except it's infinite recursion. And it's super important to call your function to actually pass in the parameter and for it to actually do something. So that brings us to the end of our module on functions. And the biggest takeaway here is how to actually write your own function, and the fact that if you're returning something, make sure you actually hold it inside a variable so that you can do something with it later on. We'll see you in our next modules.